Hello, I'm Chris. This is Gross Models. Welcome to day 27 of 30 Days Lost in Space. We're coming up to the end now. Right, today we are revisiting and enhancing on things. We're still dealing with bitmaps and our screen, but we're bringing in our dip switch and the 7-segment LEDs again. For that, we need some resistors for the dip switch, which I have prepared already. I've got some wires as well. I'm going to use some creative wiring to make it all work as it should. So I'll be getting this wired up. Basically, it needs to go to the positive rail, which is at the top there. So if I put that in there like so, there we go. That should connect up there and let me get access to these switches. The bottoms of the switches need to be connected to the board and also to the negative rail. So I'm going to do that by going up to this top one, I think. I can do that by going around there. I could bring it down to the bottom, but this, to me, seems a little bit neater just to bring it up and around there. We've got plenty of room. As long as I make sure I don't short out the legs of these against each other. I reckon that will do us. Like that. And then I can have the 3 wires coming from each of the bottoms of those down there, going to wherever we need to have them going to, which we'll figure out when we get into the video, but they're going to go up to the board up there. And this display also, again, needs to be plugged into the positive and negative. I can't remember which one's which. We have ground and VCC. So the first one, the green, is the ground, which is going to be that negative rail. The next one, the blue one, is going to be the positive rail. And the other 2 will go to wherever we need to go when we get to the video. So let's watch the video introduction and go from there and come back and wire it all up.
Good morning, Star Voyager. Another cosmic day awaits us. Yesterday, we journeyed through the wonders of bitmaps, navigating the constellations of pixels. Today, we shift our trajectory slightly, venturing into the realm of binary counters. Imagine it as laying the foundation for understanding the binary language of the universe. Using our trusty dip switch, we're going to construct a 3-bit binary counter. This is a pivotal step before we launch into the challenging task of mending our docking gear. Ready to play with some switches and send signals across the vastness of our ship's systems? Let's light up the binary stars. I want you to think of each of our switches as an individual bit. Since we have 3 switches, that means for today's calculator, we will have a total of 3 bits. When all 3 are off, we can think of it as representing 0, 0, 0. When all 3 are on, we can think of it as representing 1, 1, 1. But you haven't learned how to count in binary yet, have you? All right, deep breath, Explorer. Let's set our sights on my personal favorite way to represent numbers, binary.
Okay, here we go. I've got this all wired up now according to the wiring diagram. The 7-segment LED, or the 4-part 7-segment LED, is connected up down here and to the power. The switches are all connected up along the top there as well, where they should be. The screen is still connected up over there to power and to the 2 pins at the top. So that should be everything. But we're in the view to look at the code, which is just up there. Look. So we've got the day 27 Fun with Bitmaps code to look at and see what's what. I've just had some updates to libraries and things, so I've updated all of those down there. So it says, okay, now we know how to display bitmaps to cover the entire display. It'd be very inefficient to pre-draw every possible display, so we're just going to be doing bits of the display in different bitmaps now as well. So we need to select which bitmaps are being displayed using the dip switch. Now the dip switch counts in binary. I did interrupt her when she was about to explain binary. binary because I know binary. It's easy. It's base 2. The first digit on the right there is like the units, tens and hundreds in base 10, but they don't do tens and hundreds. They do singles, twos, fours, then eights, then 16s. It's just a different way of doing it, but can easily be done with a switch. So if we've got the first switch on, I'll switch it on. You can't see it very well from there, but the first switch on gives us 1. With them all off is 0. The second switch on its own gives us 2 because it's the 2 switch. And the third one along, if I just flick that one up, that will give us 4. To get in between numbers, if we need 3, we have a 2 and a 1, which makes 3, obviously. If I put the 4 on as well, that will give us 7. Because it's electronics and everything, we start at 0. So 7 is the maximum. It's the 8th different thing because 0 is a thing. So if I turn off 1, that gives us 6. If I turn off just number 2, then we've got 4 and 1, which gives us 5. It's just a different way of counting. It makes sense if you think about it. But yeah, so then we'll have an option of 8 different options by 3 switches, which is quite an easy way of doing things. So let's have a look at the code. Bitmaps being displayed. There we go. We're also doing things a little bit differently that I haven't played around with yet. So this is going to be interesting to work out. So we're doing including files into our thing. So we've got the Arduino H library, obviously, and the display and wire, because why not? We are saving memory on the display as we did before. That's okay, right? So what we've got now is including switch bitmaps H, which is a new file. So we need to create that up here by going up to this button on the top right, which is just off of the screen there, but it's there. And I can make a new tab, which gives us this new file there, which we will call switch underscore bitmaps H, because that's what we need to call it. So that gives a new one here. This one is still called Spy Camera because I haven't renamed it, but that's the one that we've been dealing with. And we'll put the bitmaps all in their own file to keep everything neat and tidy. So we've got a figure here. The array of pointers are right, depending on where the switches are, 0, 1, 2, 3, 4, 5, 6, and 7, tells us where to switch the bitmaps to. Okay. So we're setting the bitmap display number, pins, we're telling it where the things are, telling it where the switches are. Then we're starting up. We're just telling it that the pins are inputs, obviously, yeah. And we're calculating our X and Y offsets for bitmap graphics. Right, telling it just where the bitmap displays are and things. Build a 3-bit binary number by reading each of our switches. Showing read value of 1 and 0 for off. So yeah, when the switches are all off, we've got 0. We've got 1, we've got 2. As I was saying about binary, 1, 1 is 3. 1 is 4, 1, 1, 5, 1, 1, 0 is 6, and 0, 1, 1 is 7. It's not. That's must be an error in there. That should be 1, 1, 1 is 7. But that's a remarked out. That doesn't matter in there. As long as the code is correct in there. What's this doing? Read bit 1 to ensure a 0, 1 and save. Oh, we're reading the 3 bits. We're reading the one in position 0, that one, and the third position. Right, okay. Then we're displaying that there. And draw each bitmap in the center of the display based on its size. Okay, that makes sense to me. So is it? Yeah, right, there we go. Okay, so now we need to go to our switch bitmaps, and I shall copy in the required bitmaps from here, which I've got them down there. Let's just copy all of that. Go up to my code and paste all of that in there. Not peek, paste. So this is our bitmaps. 8 different bitmaps in there, which apparently should all be okay. We'll figure it out and see. So now that should all be good to go. If I plug this in, let's plug that into the USB. Why is USB always the wrong way around? You always think it goes one way and it doesn't. It goes the other way. This is still loading up what was loaded on it previously. So we need to upload. We've got the Uno is selected. So we'll compile that. And that should all be compiled and good to go. Taking a minute for it to compile, but we'll get there. It's working, thinking about it. Little bar across the bottom is going across, saying it's compiled. Done compiling, that's good. So we can now upload that. And we'll see that something should happen to the screen. Compiling, uploading. Is our little light flashing saying it's uploading? It is. There we go. And we've got our bitmap on there. I shall go back to the bench view so you can see it properly. We are showing 0 and we're showing a bitmap of all of the switches being down, which they are. That's good. Let me grab a pair of tweezers to adjust these switches on the fly. So if I flick this one up, there we go. We're showing 1 and the first switch bitmap has changed. Again, the scrolling is due to the refresh rate of that, so we don't need to worry about that. Let's flick that one up. There we go. 5, as I said, and that should be 7 with all of them up. Yeah. So I understand how that works, and we get a graphical representation of what the dip switches are actually doing, and a numerical representation of what it is. So we've got 1, put that back down to 2. That one up is 3. Now to get to 4, we need to put both of those off and that one on. Then we've got 5, and then just that one there, 6, and that is 7. So we've got all 8 switches giving 8 different views on our bitmap down there. So yeah, I understand that. That makes sense to me. I'm sure I could figure out from the bitmaps exactly what bits. It's obviously just changing the switch position graphic, not the whole thing, which is a clever way of doing it. I like that. So yeah, there we go. That is another day completed. I don't even need to talk to Astrid about that because that makes sense to me. I understand that. So yeah, another day done. I shall join you tomorrow. It might not be actually tomorrow, but soon for day 28 when we start the voyage home. So thank you very much for joining me. I hope you're enjoying it. I hope you're learning along with me as well. And I'll see you for more very soon. Bye-bye for now.